Hey, how's it going, guys? I hope you all are doing well. Today, what we're going to be doing is we're going to be looking again at the discriminant. Now, you do not need to write this down unless you want to, but we're going to go ahead and take a look at the discriminant again. Now, in the previous video, what we use the discriminant for is we use the discriminant to determine what type and the number of solutions there are when it comes to these quadratics, right? So, for example, if our discriminant had a negative value, then we can determine that there were two complex solutions, right? If we had the discriminant equal to 0, then we only had one real solution. Whereas if the discriminant was positive, we found that there were two real solutions. And if you can recall, the quadratic formula gives us two solutions to these quadratics. And so what we're going to go ahead and do is we're going to go ahead and take a look at the discriminants and determine whether a quadratic is factorable or not. Okay, so let's go ahead and let's take a look. That's what we're going to go ahead and do is we're going to go ahead and determine whether the expression, I'm not solving for anything, I just want to know if this quadratic is factorable. Okay, the discriminant, whether the expression can be factored. Okay, can be factored. So let's go ahead and let's take a look at the first one. And we're just going to go ahead and label it A. Okay, now the discriminant is this part right here of my quadratic formula that I put in orange. Okay, and the first expression we're going to go ahead and take a look at is x squared minus 6x minus 27. Okay, now let's go ahead and let's finish this up. Let's identify our variables. Okay, so the first variable that we have, a, is 1, right? Since it's just x squared, we assume that the coefficient is 1. All right, my b value is equal to -6. Okay, -6. And c is equal to -27. I'll make sure to include the operation, the sign before the number. Okay, now that I have that there, what I'm going to go ahead and do is I'm going to go ahead and use my discriminant. And what I'm going to go ahead and do is I'm just going to go ahead and put parentheses wherever a variable goes from my quadratic formula, right? Wherever a b goes and so forth. So since it's b squared, right in here is going to be -6 minus 4a, which is 1. C is -27. Okay, so let's go ahead and let's calculate what this equals. So I'm going to do the exact same thing. I'm going to go ahead and put parentheses here. It is important that you put parentheses so that way you don't end up with values that are incorrect. Okay, so that's minus 4 times 1 times -27. Take a look. This right here is equal to 144. Now, since that's equal to 144, that is a perfect square. Okay, so since the discriminant is a perfect square, I'm going to go ahead and write a sentence. Since the discriminant is a perfect square, all right, since it is a perfect square, this quadratic is factorable. This quadratic is factorable. Okay, now what we would do to check to see if it was factorable, right? We would find two numbers whose product is -27 and their sum is -6. And we know that these here are -9 and 3. So x squared minus 6x minus 27 is equal to x minus 9 times x plus 3. Okay, so since the discriminant is a perfect square, now if you've forgotten what perfect squares are, um, number a number times itself that so for example, 1 times 1 is a square. 1 is a square. 2 times 2, 4. 4 is a perfect square. 9. 9 is a perfect square. 16 and so forth. I can go on and on. Those are perfect squares. So since the square root of, or excuse me, since 144 is a perfect square, this quadratic is factorable. Okay, now let's go ahead and let's do one last one. Okay, we're going to determine whether the expression can be factored. So I'm going to go ahead and move this over to where I have some space over here. Okay, I'm going to go ahead and draw a line to separate my work. Okay, so let's go ahead and let's take a look at this next one. We'll call this one B. And we have 2x squared plus 7x plus 4, right? Oh, now let me go ahead and move this down a little bit. There we go. Okay, so let's go ahead and let's take a look at this one here. All right, in this case here, A is equal to 2, B is equal to 7, and C is equal to 4. Okay, now I'm going to go ahead and use a discriminant, right? B squared minus 4AC. Okay, B is 7. All right, A is 2, and C is 4. 4. Okay, so I'm going to go ahead and put this into my handy dandy calculator right over here. Okay, same thing. I'm going to go ahead and put parentheses wherever a variable is supposed to be. Makes life a lot easier for me. All right. Let's go ahead and let's finish this up. 4 times A is 2, C is 4. Check it out. Since 17 is not a perfect square, this is not factorable, okay? This right here is equal to 17. Now, if we take a look at our, if we take a look at this value here, this square root of 17, and what it would look like in the context of our quadratic formula, right? X is equal to negative b. This would be, let me rewrite this. X would equal to the opposite of b, which is negative 7, plus or minus the square root of 17, all over 2 times 2, which is 2a, which is 4, right? So this right here won't give me an actual root, and so we won't be able to factor this here. So in this case here, I would use a quadratic formula to solve it. Okay, so since we have this here, since the discriminant is not a perfect square, this quadratic is not factorable. There we go. So that's it for today. Have an awesome rest of your day.